All right, in this video, we're going to jump right into the programming techniques. But first, I want to give you a chance to at least think about, or give you a chance to practice decomposing this problem. So if you remember, our goal was to write a program that will compare different integration techniques. In order to do that, obviously, we need to write some code that will actually do each one of those techniques. And we talked about each one of the techniques in the last video. So, but I claimed that there's one thing that each one of these algorithms did that we're going to need to program up. And I'm talking real slow to give you a chance to think about it. So think about each one of those, or any kind of integration numerical technique that you've ever seen. What is the one thing that you have to do right at the beginning? All right, so since I gave you a little bit of time, you can hit this pause button if you want to think about it for a second. So if you're given some function that we're trying, so this is f of x, and we're trying to figure out the area underneath that curve. If I'm going to use an integration technique, the first thing I'm going to do is break this thing up into evenly spaced elements. So a vector. So if I'm given a and b, and n, the number that I want to break these up into, then I should be able to produce a len, it's called len space. And so we'll see that here in a second. But we're going to, in MATLAB, I think NumPy, Numerical Python, uses the same wording that MATLAB does, which is fine. And we're going to use the same one that Numerical Python, NumPy, because we're going to get to it here in a bit. But I want you guys to program your own version of this len space. Okay, so let's jump right into it. Each one of them, so you can read the doc string here. Produce n equally spaced numbers starting at a and ending at b. A is your initial value, b is your final value, and n is the number of values in the sequence. So a vector equally spaced. For example, if you're going from 1 to 4 and you want 7 of them, so 1, 2, 3, 4, 5, 6, 7, we're going to have 0.5, it looks like, in between each one of those. And so we want to produce something, or I want to hit Shift Enter, or I'm sorry, F9 here in a second, and I want that to work. Okay, so how are we doing it? Well, you got to start off with a list, and that's what we'll do. That'll be our vector, and we got to come up with some whatever delta is going to be, and delta is just b minus a. Let's see, b minus a divided by, if that sucker's 1.5, 7 minus 4 would be 3. 7 minus 4 would be 3 divided, no, 4 minus 1 would be 3. That's what I'm looking for. 4 minus 1 would be 3. And then we got to divide by 6, so n minus 1. All right, so that would be our delta. And what you're doing is you're considering, and I think I said this in the last video, you're considering the interval and the fact that you need 2 points, a point on the left and a point on the right, in order to make an interval. So you're having one extra number in your sequence, if you will. So for I in range n, so that tells me how many I'm going to do. I'm just going to simply go in there and go v.append. Let's see, let's append a, because that's our starting point, and then plus I times our delta. I think that should be right. Let's see what happens. And then we're going to return v. All right, let me run this and see what we get. And it looks like, so again, from our example up here, 1, 1.5, 2, 2. Okay, so it's doing what we think it should be doing. What if I did 100? So again, you want to write this thing, oh, look at that. So it's giving you a whole bunch of numbers. So giving you 100 of them in between 1 and 4. So that looks right. Okay. So the next thing we want to do is we want to develop this left-hand rule by passing a function in to another function. So that's what you want to do. Remember when we were talking about the height, the left-hand rule, we were worried about the left-hand point being giving me the height. Well, how do I find the height? Well, you got to use the function value. So we're going to pass in a function. So let's define our left hand rule, and I'm going to pass in another function. I'm going to pass in A, I'm going to pass in B, and I'm going to pass in N. Remember, we need to know our left and right limits, and I need to know how many intervals you want to make. And in this case, it's not even intervals, it's the number. So N minus 1 is the number of intervals that we're going to make. Remember that. So let's go. X list is equal to, well, how can I get a list of all the X values? You said we're going to use that function that we just created, right? Hopefully you said that. I was giving you a second to think about it. And then H is equal to, so H is the same H as delta up there. I guess we could use delta too. So let's use delta. I'll say delta X. Is equal to E minus A divided by N minus 1. So it should be the same as that one up there, and it is. All right, and then I'm going to calculate my area. So I'm going to start off at 0, and then I'm just going to add them up as we go through. And then 4x in X list. Print. Let's print F evaluate. So I just want to make sure that this is actually doing what I think it should do. Evaluated at X. Let's tell it that, 2F. X dot 2F. So I just want to make sure that when we pass in our area, so first of all, let's create a function here, and I'm just going to do a lambda. X is X. So F of 2, let's just make sure that works. 4, and it does. So I can take this out now. And then left. And understand that the left hand rule is not doing anything yet. I just want to make sure that it's going to do something. So we'll go from 1 to 5, and we'll have 10 intervals. That's not. Oh, I didn't do it yet. Let's try it again. Okay, so it is 1. So let's go back and remember what we're trying to do. F evaluated at 1 is 1. Yeah, that makes sense. 1 squared. 1.44 is 2.09. I don't know. 2.3. Let's see. Is it 5? Yeah. Okay. So I know what this is. 2 squared is 4, 3 squared is 9, 4 squared is 6. Okay, so it is doing what we think it should do. I'll turn this back to 10. So left-hand rule, right now, all it's doing is printing out the function values. Now what we want to do is we're going to come back in here and we're going to calculate. So remember what this thing is supposed to do at each step. It's supposed to, so y0, or we'll say y0 because I don't have any other ones. So y0 is just simply equal to f of x. And then area is equal to equals delta x times y0. We'll say y0. Now, is this right? Let's think about this for a second. And this is one of the reasons why I wanted to harp on this in the last video and this video. What's happening here? This is going to every single one of our x values. And do I have an interval for every single one of our x values when I'm using the left-hand rule? The answer is no. I need to leave off a number. And which number do I need to leave off when I'm on the left-hand rule? The right, the very last number, right? I'm using the left. So if this are my interval, that's the last one that I want to have. I don't want to mess around with B. I'm just using it. When I'm on the right-hand side, I'm not using A. I'm going to start off here and go over. So how do I do that in a list? I want everything up to the -1. That should work. Let's take this print thing off here just to make sure. And it looks like it stopped, right? So it stopped before it reached 5, right? Yeah, that's what it did. Okay, so that's good. And then what are we doing here? Let me take this thing back out. And I want to return the area. When I'm done with all the values that are in the X list, I want to return what the area is. And let's do it again, F9. And it looks like 36.13 is that number. Okay. Happens when I make it 100. What happens when I make it 1,000? What happens when you make it 10,000? Is it going to bog down on us? Maybe not. 100,000. Still not bogging down. I want this thing to bog down on us. There we go. So it bogged it a little bit. So it looks like it's probably 41 1/3, and it's just getting closer and closer to 41 1/3. If I do one more, it'll definitely bog down now. See, it takes 10 times as long as it just did. And it looks like it gave us another digit in precision. Okay. That's how you do it, and that's all I got for this lesson. I will come back and do either Simpsons or trapezoid rule for the next video.